Here we have an example of a double integral over a region D. We're going to evaluate the double integral over the region D of x squared plus 2y dA, where D is bounded by y equals x cubed, and x is greater than or equal to 0. A preliminary judgment lets me know that because we see y as a function of x here, we're likely going to have a better time setting this up as a type 1 region. We'll do both for the sake of practice because I think that's going to be good for us to do. Now, first and foremost, though, we should probably sketch the region in question and sketch the actual boundary functions. Y equals x, I couldn't ask for a more basic function. Here's y equals x. Now, for y equals x cubed, that one is going to look more like a cubic polynomial with a little bit of wiggle to it right around the origin. And we also want that x is greater than or equal to 0. So the only little sliver that I'm talking about is this little sliver right here in the first quadrant. If we were to zoom in on this a little bit, we would see something that looks a little bit more like this. Not a great picture, but hopefully it gets the point across. Now again, we have the option of setting this up as type 1 or type 2, and we're going to start with type 1 since that seems to be what the problem is sort of motivating us to do. Now as a type 1 region, we want to bound this thing from top to bottom and pose ourselves the question, which function is on top and which function is on the bottom? You'll notice that within the given region, the straight line is the region that is on the top. Therefore, y equals x will be the upper bound, and the cubic is what's on the bottom of the region. So that'll be y is bounded between x cubed and x. Now, additionally, we need to know the points of intersection between these two things. Normally what we would do is set these two things equal to each other and solve for x. I hope it's not too much of a stretch for me to simply point out that one of them is going to be x equals 0, the other will be x equals 1. You'll also notice that x equals negative 1 is a solution of that, but negative 1 is referring to the point of intersection that's outside of the region in question. Therefore, we only need to worry about x going from 0 to 1, as is emphasized by the fact that we're told that x is greater than or equal to 0. So setting this up as an iterated integral, the double integral over the region D of x squared plus 2y dA is going to be, the last integral will be with respect to x and it'll go from 0 to 1. The first integral with respect to y will go from x cubed to x. And this will be x squared plus 2y. And in order, we go with respect to y first, then with respect to x. This is the setup of your iterated integral, and undoubtedly it is the more difficult part. Now, to actually evaluate this thing, we'll start by integrating with respect to y. Integrating with respect to y is going to give us x squared is a constant. Integral with respect to y will be that constant times y, plus the integral of 2y with respect to y will be y squared. That's going to go from lower bound x cubed to upper bound x. Evaluating these will give us, for the upper bound, this will be x squared times x plus x squared minus, plugging in the lower bound, this will be x squared times x cubed plus x cubed squared. Holy crap, we need to do a lot of algebra. Good news is, once that algebra is done, it'll be just a little bit more power rule until we're done. So with that in mind, x cubed times x will be x squared times x will be x cubed plus x squared minus, we'll add those exponents, x to the 5th, and then we'll multiply those exponents to get x to the 6th. This will be a very straightforward integral making use of the power rule. This will be 1/4 x to the 4th plus 1/3 x to the 3rd minus 1/6 x to the 6th minus 1/7 x to the 7th, going from lower bound 0 to upper bound 1. When we plug in the upper bound of 1, we'll simply get all of the coefficients. So 1/4 plus 1/3 minus 1/6 minus 1/7. And plugging in the lower bound of 0, every single term will zero out. I like to refer to this as a lot of 0. From here, rather than getting a common denominator for everything, I'm going to do something considerably lazier and say 1/4 plus 1/3 minus 1/6 minus 1/7. Gross. Math, enter, enter, will convert that to a fraction for me, and hopefully you all can see that it says 23/84. 23/84. Next up, we're going to set up and evaluate this as a type 2 region, and hopefully we'll get the exact same result. Now, in order for us to do so, a little low on space, so we'll go ahead and recopy some of the stuff on the back of this piece of paper. There's y equals x cubed. Region in question, but this time we're going to be going from left to right within our region. So as a type 2, we'll need to express x being bounded between two functions of y, and then y goes from a constant to a constant. Now with that in mind, we'll need to put both of these in a form where we have x as a function of y. The line will be very straightforward to solve for x. In fact, I did it while I was talking just now. This one, we will get that x is equal to the cube root of y. Now, in anticipation of the rules for exponents that we're going to need, we'll also express that as y to the 1/3 power. Now, taking a look at our region, you'll notice that the left boundary is our straight line. That's x equals y. The boundary on the right is our curvy region, and that'll be x equals the cube root of y. Or as I mentioned just a moment ago, we'll call it y to the 1/3 power. Now, on the other side of this page, we had solved for x and got that x was 0 and 1, but because x is equal to y on that line, y will also go from 0 to 1. That means that to set up our double integral over the region D of x squared plus 2y dA, just going to verify real quick that that is the function in question. Good, my memory's not too bad. This will be equal to, last integral will be with respect to constants, that'll be from 0 to 1, and the first one will be with respect to variables, that'll be y to the 1/3 power of x squared plus 2y. First integral is going to be dx, second integral is going to be dy. So, hopefully when all is said and done, our final answer will still be 23/84, indicating that I'm either right or I screwed something up so perfectly that it looks like I'm right. Our first iterated integral will be with respect to x. Integrating x squared with respect to x, I will be getting 1/3 x cubed. 2y with respect to x is a constant, therefore that will be 2y times x. That's going to go from lower bound y to upper bound y to the 1/3 power. Plugging these quantities in, we will get 1/3 of, oh well, this is convenient, y to the 1/3 cubed, that's very convenient, plus 2y times y to the 1/3, minus, plugging in our lower bound, I'm simply going to replace all of my x's with a y. So that'll be 1/3 y cubed plus 2y times y. Ooh, lots of videos, back to back. Next, let's simplify with some algebra. Ooh, not gonna make it.